Hello, this is CodeJoy, and I'm showing how I defeated the algorithm of how I solved the algorithm of valid parentheses. And as you can see, it says success, better than half the people, which isn't too great. Sometimes I get it around 90. But I'm going to try to explain how I did it. So the same algorithm is here, but I like it here better because I did some comments. And basically, we have a function called isValid that takes in a string of s, okay? And down here, you can call it, you can say, like I'll do the first one, isValid, um, parentheses put together. That's the correct way to do it. So when I run the code, the top one says truth. But for example, if I did it this way and then this way, that's non-mathematical. That doesn't make any sense. So it would say falsity at the top. The reason it says falsity is because in my algorithm I have it logging falsity there. It's a special type of false. But basically what my strategy was is I have three variables, paren, curly, and bracket, and I set them all to true, and then I have an empty array called R. Now, the reason these all start out as true is because when you have an S that is just a curly brace, let's say, that the parentheses are fine. For example, let's say you have curly brace and then parentheses. This would return true because that you have an opening and a closing, an opening and a closing. But if you take the parentheses out, it's still true. So paren starts out at true. But if we go back, if we do it the wrong way, as soon as it sees this facing left being a closing brace, it's where's curly? Curly. If you see a closing brace and curly is false, blah blah blah, but curly starts out as true. So if you see a curly and it's true, return false. This is so hard to explain. Sorry. But let's do this. We'll do like this so you can see. This will say falsity 2. And let me get rid of all these. So we get falsity 2 for this. And the reason why is because it falls into this if statement. Because basically, my strategy is to start them off as true. When I get an opening brace, then I switch it to false. So if we look at a parenthesis, like let's say just one parenthesis like that, that would be false. And I'll show them. The reason that's false is because um, um, I'm only going to say it's true if all the things are true. If paren is true, bracket is true, and curly is true. I start off as true, but as soon as I see that one parenthesis here in between the two quotes, tick marks, um, I'm switching it to false. So basically, when you see, let's see here, when you see a string of parentheses like 3, you know this will be true because we have 1, 2, 3 on the left side and 1, 2, 3 on the right side. But if we don't have 3 on the right side, like let's say we do 1, 2, 3 on the left and then 1 on the right, this would be false. And the reason for that is when we get that second and third and the first, second, and third of the parenthesis, the opening parenthesis, we're setting the parameter or the variable paren to false. The Boolean, we're setting it to false. And I only set it to true if man, it's complicated how I did it, but basically I'm keeping track of the things in R, and then if R includes a lefty opening parenthesis, then I reset it to false. So if s of I, which is iterating through the string, so if the one we're looking at, because we look through all of them when we have this right here, if the one I'm looking at is an ending brace, normally we set it back to true because we want it to be false. Like this one on the left makes it false, and it makes paren false, and then paren is still false, and then paren starts to become true. So it's really only these two that make it false now. And then it starts to get more and more true until it's completely true if I do them all. And that's because R is keeping track, and oh man. But anyway, so all this code here is for the parentheses. And then it's just basically duplicated, but for the curly brace and then for the bracket. Also, I'm only returning truth if R is 0. And the reason why R length is going to be 0 is because every time I get that closing thing, I pop it off. So when I get the closing parentheses and the parentheses are false, that means we have an opening parenthesis. So I have an opening parenthesis and then a closing parenthesis. When I iterate through the opening parenthesis, I set paren to false. And then when I get the closing one, like let's say we're looking at this example, which would be true, the opening and the closing, the most basic one. Well, first we look at the opening, and I set paren to false, and I add R. R would be have a parenthesis in it, an opening parenthesis. Then I look at the second one, and I say if parenthesis is false, and I'm looking at the second one, the closing brace, and R, the most recent thing in R is a left brace, then I'm setting it to true, meaning we closed the opening. And then I pop it off instead of adding the second one to R, I pop it off so R is reset again. Because if it was like this, these two can be ignored. Like all of these, as far as R is concerned, can be they can be popped off. Once you've closed the opening, it doesn't matter anymore. Um, so R becomes like this, and then before it gets this, instead of adding this to it, we just pop it so that it becomes the length of 0. And so at the end of it, R should be 0, and all of these should be true. And if you just do nothing, it would return true. But in this problem, they're always going to give you at least one. The string is at least one thing long, so you don't have to worry about that. But yeah, so basically I say there's only 6 possibilities in the thing. And so I look at it, I say, is it a parenthesis, a curly, or a bracket? And then is it opening or closing? If it's closing and all these are starting out as true, if I get if it's closing and parentheses are true, then I just say falsity. So for example, if I just go like this, that would be falsity. And if it's like this, it would just be false. Anyway, so it's pretty cool because you can make shapes. And you think, how does my brain check this? You check, what symbol am I looking at? Is it an opening or a closing? If it was a closing, this would be false. It'd be a falsity. Falsity 1. But the brain, you look at it, you make sure the first thing you see is an opening of any of them. And then like for example, that is truth. So the brain looks at one thing at a time. It says, am I opening? Yes. Am I curly? Okay, so keep track of R is a array with stuff in it, and it would be like that. You're keeping track of that. Then you look at the second one and you say, okay, I have this now. And then you get to the third one and you say, okay, now the parentheses is going to close, so I pop it off. So now when we look at this next one, all we have in R is the unresolved parentheses. R is a list of, it's an array of the unresolved parentheses that you're keeping track of in your head. So when we get to this one, we say, well, we have an opening in R, so this closing one pops it off. So then by the time you get to the end, R should be empty for it to be true. And if there's any unresolved, then it's false. So R would be the unresolved opening parentheses that never got closed. That's why R's length should be 0 right here. And these and signs mean and. So I'm saying if the parentheses are, if paren is true and bracket is true and curly is true, meaning they've all been resolved and there's nothing that's unresolved, then it's the truth. Else it's false. And then, but I also have all these return falses just in case we get a resolution without an opening. So, for example, if if we get something like that, that would be a falsity. 2. I believe it was 2. Yeah. So, anyway, that is how I did it. I believe I started to explain it well at the end. Um, so, create 3 variables that are booleans that are all true. Keep track of the unresolved opening braces, and then iterate through, and then do some if and else statements of if it's an opening or closing. Do some stuff to R, and then you do the same logic with each different type of parenthesis, and then the else will cover everything else and just say false because it's not legit unless it obeys those principles. So that is the end of my explanation of how I solved the problem of valid parentheses given a string s and the characters determine if the input string is valid. For example, this is true, and this would be false because this one has an opening that never gets resolved, and this one is a closing that never opened. So it's doubly false. All right, so thank you very much, and that'll do it.